So 2 weeks ago, Google hosted an event at their Google offices in New York. There were about 80 people in the room, most experts from Netflix, Google, and Bloomberg. And I was listening in to a conversation from a reliability engineer from Google, and he said something that got me really excited. And it's the topic we're going to talk about today. It's how companies are using LLMs to generate structured output, such that they can pair them with traditional systems like databases and APIs. We're all used to LLMs as chatbots, and we can interact with them all the time, ask them questions, but there's a human in the loop, and that's not what us engineers want. We want systems, right? We want to build stuff that LLMs can connect to, its databases, its APIs. That's how our systems work today. And LLMs are not capable of doing that because they output natural language. I mean, you ask ChatGPT to generate something and it'll output a string, not a structured output like JSON or like XML. And databases and APIs need that. So when you can combine those two things, the brightness of LLMs and the power of APIs and databases, you get systems like this. And this is what we have today, and companies are doing it, and they're letting users use natural language and vision and audio to generate structured outputs. And it looks like this. You ask a natural language query, and then it extracts the important parts. Here, it's asking the user, hey, what flights do you want to look for? What price range? What dates? Right? And what this does is effectively convert this into a database query. So it shows the flights for that query, but it's no longer natural language. It's structured outputs now. So it integrates very well with existing systems. And the same goes for this company. It's called Dub. It's a link shortener company. And they're doing the same for the analytics website. So you can ask natural language queries, and it'll show you the clicks for those dates or for those countries, right? So the question is, how can we do this in Python? Today, so the first thing we're going to talk about is coercing LLMs to generate structured outputs. And by that, I mean JSON or XML or, going forward. You got the whole presentation in 2 minutes. We're going to see the original approach, which is what people are doing now to make LLMs generate structured outputs. And then I'm going to show you the better way, which is what companies are doing today. Then I'm going to show you a live demo if we have any time. And finally, I'll show you around the whole ecosystem of tools that exist today, so you can choose any one that fits your system better. So let's begin. What's the first approach to making an LLM output structured text? Well, you just ask for it, right? You just ask, hey, can you generate JSON for me? But that's kind of dangerous. That's not what we want in our systems, because models can hallucinate, which means they'll make up fields. They can drop fields, which would break your query, and they can also add additional text. If you've ever done this, maybe your model outputted something like, here's your JSON, and then the JSON file, which you cannot parse. That's not valid JSON. So what OpenAI did, well, actually, I wanted to show you this picture. It's from the Google meeting I told you before. This is a staff engineer from Google, and right here, he's asking his model, hey, respond in JSON format. So people are still doing this, and this is not reliable. And you can't build systems like this because you can't trust that output. So what OpenAI did was in November from last year, they implemented JSON mode, which just solves one of the problems by forcing the model to always output JSON. But you still have the hallucination problem, which means it can still drop fields. And also, data types may not be valid. For example, if you wrap an integer in quotations marks, it becomes a string, no longer an integer, and that will break your database query. So yeah, output parsing is unreliable. That's not the way I want you to think about LLMs generating structured outputs. because you also have to manually validate that data. See, if you don't trust the types the model is returning, you'll have to validate every single type. So, for example, if you have an employee with a role, you've got to make sure it's a string. If you have a name, you've also got to make sure it's a string, and if it's alphanumeric, and that is for every single data type you have. That's not scalable, and it's not reliable. So the question is there a better way? And of course, there is. That's why we are all here. And I wanted to show you this video, and this is what we're going to use. This is a very special guest, Samuel Colvin.
Hey, I'm Samuel.
I'm going to have to do this because the mic is not working before. But this is the creator of Pydantic, Samuel Colvin.
Hey, I'm Samuel, the creator of Pydantic. Pydantic is a data validation library for Python, where we use Python to both validate data and control how structured data is serialized. Thanks so much, Jose, for talking about Pydantic today. I hope you enjoy the talk.
So this is brilliant. Pydantic, right? Pydantic. If you've heard of it, which most of you probably have, it's a data validation and type-safe objects for Python. So the problem of types, of unsafe types, it becomes so easy, and I'll show you how easy that is. It's just this. With Pydantic, you just have to tell the attributes that you want to get, and then their types. And it'll automatically validate that for you. So that's the structure output we want, because it's type safe, and it comes with validation. And you can even add data validation like this. You can ask it to, the first name should have a max length of 40 characters. The last name must do the same, etc., etc. And finally, and one of the most valuable things for this application is you can add a custom human-readable description to Pydantic models. So now if you're following this, well, you can see this is the perfect output we should be aiming for. But then the question is, how do we get the model to output a Pydantic model? This is the answer. This is very new. This is from June last year. Now you can ask LLMs to output a function, or to try to call a function, right? You can use tool calling. And you can use tool calling to ask the model to generate a Pydantic object. And this is what that looks like. This is it. This is the JSON structure for asking the model to output a function, or to call a function, rather. And all you have here, look, it's the same. It's just you create a Pydantic model, you pass that in JSON format, and you ask your model here, hey, use this tool. And that's it. You've got an LLM that can generate structured outputs that you can trust and that are valid. But as you saw, this is very cumbersome. It's very hard to maintain. So what you do, and here comes instructor. And this is Jason, who I interviewed before this talk, so I could show you his ideas on the package, but I forgot to record audio, so I'm just going to skip it. This is Jason Liu, and he created instructor, which I'll just show you in a second. Converts, I mean, it just makes that whole JSON structure so much easier, and this is all you need to make your LLM's output structured data. It's the same API you're used to using. Look at it, it's just a Pydantic model followed by a patching OpenAI's module, and then you just have this new argument response model where you just pass the Pydantic model. And that's very exciting because you've just modularized and made it so easy for LLMs to output something you can trust. This is another example. You can also use Anthropic if that's your tool of choice. And this is a quote from Simon Wilson. He's one of the co-founders of Django, and he's a very brilliant open source contributor. And this is from PyCon US, which was three weeks ago. And his way of thinking about new technologies, like Instructor, is what can I do with this technology that I couldn't do before, or faster than I could before. So if you look at this code, it just solves so many problems for you because you can just pass this model or an LLM output to any downstream system. Now I'll show you a quick demo of the kind of things you can do very quickly, because the thing about this is you can build stuff very quickly and get going. You can see my screen over there. And I can run this and tell it. Forgot to explain. I want to show you what the application does beforehand. It's a very simple application. Say you're a healthcare company, and you've got your patients sending their data through an online form, right? And then you create a patient in your database, then you create an appointment in your database, so no two appointments happen at the same time. And finally, you create a Google Calendar event so that the doctor knows what events he has and the patients too. It's very simple. And look how simple it is to do the same, but with an LLM. You just define the two models. You create an extraction function, which uses the response model. You extract the text. Say this is any input that LLMs can capture. It can be text. It can be audio. It can be images. And you do exactly the same because your downstream systems stay the same. They stay the same. You can just dump that model, which is just converting a Pydantic object to JSON, and you've got the same. So here's the application. It's what this looks like. Hey, my name is Jose. I'm 25 years old. My phone number is 1234, and my email is healthy@patient.com. Now, I'd like to schedule a meeting for tomorrow at 5 p.m. Now what this does, it's sending the audio to OpenAI, and it created this event. I'll just show you in a second. And this is for 5 p.m. Today's the 7th, and it created an event for the 8th. It effectively communicated with Google's Calendar's API. And what's better than that, it didn't only connect to an API, but if you look at here, I used SQLite for this because it's an easier example, but if you open this database, you can see that we now have an appointment here. Browse table. You can see the appointment here, and you can also, can you see that? And you can also see the new patient information here. Can I zoom in? I can't. But if you look closely, that's me, that's Jose, and that's my phone number, and that's my email. So I got the model to communicate with an API and a database. And that opens up so many new applications. I'm going to go back to the slides. I'm going to go back to the slides, and I just show you what Instructor does, and it's the library I like the most. It's the library I like the most because it's easier to add. You just saw it. It's almost 2 lines of code, but it's also very easy to delete, and that's Jason's new philosophy. It's good code should be easy to add, but it should also be easy to delete. So I encourage you all, if you want to try this out, use Instructor for your first step. But then the field is growing so much because people realize the value of these tools that can make LLMs output structured objects. So there's plenty of tools now that can do that. I'll just show you a couple. Miroscope is a new LLM framework that can do this. If you want to try something new, it's supposed to be more Python-like. You can try it out. There's Marvin AI too that can do this. Then there's Outlines, which is the same as Instructor, but for models hosted in Hugging Face. If you're using LangChain, the entire framework, you can also do the same inside that framework, and you'll probably be better off doing that than using Instructor. And the same goes for Llama Index. They also have their own functions, but you've got to still keep your code inside their framework. So this was a very almost short talk because I wanted to make it simple and make the message very clear. This is just making LLMs output structured things. It's just that. But then it allows you to connect to so many of the current states of how systems are built. So yeah, structured generations make LLMs compatible. Use Pydantic with tool calling to make your LLMs generate structured outputs. And use Instructor if you want to get started quickly. But most importantly, and I encourage you to do this, is build things, use this technology to build things that you couldn't build before. Thank you very much.
Ya, sonido. No sé.
¿Cuánto hay? ¿Como 20 minutos?
¿Qué tipo van a hacer? Uf.